Hello, everyone. Good afternoon, dear authors and invited guests. Welcome to Technical Session 7D. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, New York, USA. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held yesterday in New York, USA, and the virtual event is being held through Zoom yesterday and today, that is 23rd and 24th of May 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for their presentation and 3 minutes for question answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants. Kindly stay connected with us till the closing remark. If you have any query or any update, you can write it to me in the chat box. So let's move forward and let me introduce you with today's session chair, Dr. Shafi Pathan. Dr. Shafi Pathan is a professor in the Department of Computer Science and Engineering at MIT School of Engineering, MIT ADT University, India. With 24 years of academic experience, he has authored 5 books and contributed 1 book chapter. Dr. Pathan has presented 39 research papers in national and international journals and conferences. I request our respective session chair, sir, to kindly address our participants.
Good morning to, good afternoon to all. I'm Dr. Shafi Pathan, representing as said by MIT ADT University, which is located in Pune in India. Being a session chair for the conference is always advantageous for a person in the teaching community like me. The reason being that we get to know what is current technology and techniques going on in the market. It is a learning experience. At the same time, if any way we can contribute to these things, it will be always a joyful experience. I'm really, for this, I'm really thankful to GR Foundation, Dr. Amit Joshi, and my friend Nilanjan Dey, Parikshit Mande, and Prashant Dote. I wish you all good luck to all the participants. Thank you.
Thank you, sir, for highlighting the importance of session chair in the conference. Now, let's move towards the first presentation. For the first presentation, I like to call Patuani for the paper title, A Multidimensional Review of User Perceptions in Technology Adoption. I request the presenter to kindly proceed with their presentation.
Okay, thank you. Hello, everyone. My name is Patan Mapande, and I'm pleased to share the insight of our research, recent research titled A Multidimensional Review of User Perceptions in Technology Adoption. The research focuses on user perceptions when adopting technology, and this study reflects a collaboration focused on understanding how users and why users adopt technology in today's evolving digital era. So the purpose of this presentation is to provide a comprehensive comparison of 5 user perceptions model in technology adoption and discuss their relevance in shaping practical user-centered strategies. So this is the content of the presentation that I'll be sharing with you today. Why is it important to understand technology adoption? Digital transformation is reshaping every industry, such as education, healthcare, finance, and beyond. The success of new technologies doesn't depend solely on technical innovation, but also on how users perceive and accept these tools. Understanding adoption behavior is essential to improve engagement and system usability, design emotionally and cultural responsive systems, support inclusive access to innovation. A holistic review of user perceptions model. So this study goes beyond isolated analysis by offering a side-by-side synthesis of 5 major models, which is the technology acceptance model, unified theory of acceptance and use of technology, diffusion of innovation, innovation adoption life cycle, technology readiness model. So the key contribution when it comes to this module, dimensional perspective that integrate cognitive, emotional, social, and contextual factors in understanding technology adoption. So this approach helps bridge theory and real-world implementation, offering practical guidance for researchers, developers, educators, and also policymakers. Beyond technical efficiency when it comes to understanding user perceptions, adoption is shaped by psychological factors, including optimism and insecurity. Social influence plays a role as peer approval and cultural norms affect user acceptance. So emotional readiness impacts adoption, comfort, and trust drive engagement. When it comes to integrated approach to deeper insight, the study compares five major models, which is TEM, UTA, DOI, innovation adoption lifecycle, and also TRM. Each model offers a different lens, combining usability, social factors, diffusion patterns, and also emotional traits. So a multi-dimensional view, it helps to predict and enhance technology acceptance strategies. With a start with TEM, TEM has two forecast attribute, which is the perceived usefulness and also perceived ease of use. Users adopt technology if they believe it enhances their performance, or else if the simpler a technology is to use, the more likely users are to embrace it. So effectively, TEM, it predicts user intentions to adopt technology based on perceived utility and ease, widely applied across industries like education, e-commerce, and also healthcare. But when it comes to its challenges, it lacks emotional and social dimensions, does not account for user trust, discomfort, or peer influence. It often too individualistic, overlooking cultural and also collective adoption dynamics. The UTA, it focuses on social influence and also facilitating conditions whereby users' adoption decisions are shaped by peer approval, cultural norms, and also organizational expectations. Also, availability of resources, infrastructure, and technical support, it also enables smoother technology adoption. Its strengths, it recognizes external factors. Technology acceptance is not just individual, but influenced by social pressure and system accessibility. It also helps predict adoption pattern in workplace settings, education, and also collaborative environment. And then the challenges when it comes to UTA, that it's sector-specific variations, require model adaptations. What works in education may not directly apply to healthcare or finance. Just an example. Does not fully account for evolving digital trends, such as remote work and decentralized technology adoption. The DOI, it examines how innovation spread through social networks and influence adoption behaviors. It highlights the role of communication channels in accelerating or hindering diffusion. It considered compatibility, relative advantage, reliability, and observability as key factors in adoption. It emphasizes social influence and cultural norms, peer approval, and leadership drive adoption. It explains how early adopters shape mass adoption through social proof and visibility. It also helps predict adoption curves, aiding policymakers and businesses in strategic planning. There are challenges with DOI. It struggles to adapt to rapidly evolving technologies that don't follow traditional diffusion patterns. It may overlook digital transformation speed and disruptive innovations like AI and blockchain. It assumes gradual adoption stages which may not apply in hyper-connected digital ecosystems. Innovation adoption lifecycle model, it categorizes adopters into 5 groups, which is innovators, early adopters, early majority, late majority, and also laggards. It explains how technology adoption happens in phases with different user groups embracing innovations in different times. It highlights risk tolerance and also social influences as key factors shaping adoption progression. It provides a strategic framework for understanding how new technologies gain traction. It helps businesses and policymakers tailor rollout strategies for each adopter group. It recognizes that adoption doesn't happen regularly. Some users need tangible proof before they commit. And then its challenges is just that it doesn't fully account for psychological factors like optimism, discomfort, or fear of change. It assumes adoption follows a linear process, which may not hold an indestructive technology environment. It may oversimplify user motivations, overlooking emotional and cognitive readiness in decision making. The TRM, it focuses on optimism, where positive expectations about technology enhancing life and efficiency. Innovativeness, willingness to experiment with and embrace new technologies, discomfort, anxiety, or skepticism towards a complex digital tools. Insecurity, distrust in technology's reliability or security. So it identifies psychological barriers that impact user adoption. It recognizes emotional readiness as a key determinant in technology engagement. It helps tailor adoption strategies by addressing user anxieties and motivations. It also works best when integrated with behavior-driven models like TEM and UT. Alone, it lacks predictive power for actual technology usage behavior. It also needs contextual adaptation to different sectors and demographic groups. The key findings regarding those 5 models, it's ecological readiness matters where users with optimism embrace technology faster, while discomfort creates hesitation and resistance. Social influence, it shapes adoption, where peer validation and cultural alignment play key roles in driving user acceptance and adoption. Trust and risk are crucial. Concerns about security, privacy, and system reliability affect users' confidence in adopting new technologies. Adoption is phased and contextual. Different user groups adopt technology at varying rates, requiring tailored strategies for each phase. The practical takeaways are for technology adoption when it comes to developers, they prioritize user-centered design by integrating features that accommodate emotional readiness, such as intuitive interfaces, trust-building mechanism, and also personalized user support. Educators, they consider student varying digital adaptations level when introducing learning tools, ensuring that resources are accessible, engaging, and tailored to different levels of technological familiarity. When it comes to policymakers, it tackles security concerns and also accessibility barriers by enforcing strong data protection measures, promoting equitability, digital access, and also ensuring technology adoption policies are inclusive and user-friendly. Conclusion and future research regarding those 5 models that we reviewed. Technology adoption is shaped by multiple dimensions, which is cognitive, emotional, and social contextual. Future research, hybrid models, cross-cultural studies, longitudinal tracking of user adoption trends. A user-centered approach ensures sustainable technology engagement. These are the references of some of the studies that we have reviewed. Thank you.
I'm audible.
Yes, sir, you are audible.
Okay, good. For morning, very good presentation you have given. Hi.
Pardon?
Very good presentation you have given.
Thank you.
Fine. You said about models. May I know from where you have taken these models? Five
Can you
models you
repeat?
stated. 5 models you stated. Can you tell me from where you have taken this information? What is the source of information here?
Regarding the models that we have reviewed.
Yes.
Okay. For example, when we have to review the TRM, which is the technology readiness model, we have the early adopters, we also have the early majority, and also the late majority adopters. When it comes to early adopters, the opinion leaders who influence others by adopting innovations earlier. So most of the people, they expect somebody to already have adopted the technology, who can tell them about how the technology is best so that they can be able to adopt. Then also, when it comes to the early majority, it means more people are conscious, but they do want to adopt. And when they do the adoption, they adopt the technology at once the benefits are clear, once they know that if we adopt this technology, this is the benefit that we're going to get from that new innovation. Then when we move to late majority, for example, it's when users, they are skeptical to adopt the technology due to the necessity or maybe due to social pressure. Then that's when they can be able to see if it is necessary for them to adopt the technology. And the last one, where it's the laggards. Laggards is those users who are resistant to change, who they adopt only when the technology becomes unavoidable.
Acha. Okay. We will conclude here. Wish you all the best, Satwan.
Thank you.
Thank you, ma'am. Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Tapod Bengisi for the paper title Advancing Neuroimaging Diagnostics, the Role of Transformer in Alzheimer's and Parkinson Dissection. I request the presenter to kindly proceed with their presentation.
Okay. Good afternoon, good morning, and good evening, wherever you are from. I am Stafford Benges, and I'll be presenting on advancing neuroimaging diagnostic, the role of transformer in Alzheimer and Parkinson detection. Okay, by the way of introduction, we are going to have a quick look onto background, research review methodology, experimental result, and conclusion. So, by the way of discussion, and I'll give a brief discussion on the two diseases, Alzheimer and Parkinson. And Alzheimer and Parkinson are kind of two diseases which are interrelated, and all of them are neurodegenerative disease. I mean, these are diseases which are incurable, and all of them affect the neurons, and they have different repercussions, but in common, they affect the neural system. And mostly currently, they affect the senior citizen. And looking on two different, the WHO published is over 1 million people are affected with Parkinson, only in USA, and over 10 million too worldwide. And Parkinson is the second one, preceded by Alzheimer, which is at the highest number of patients. So in looking onto this disease and looking onto the existing research review, most of the work which has been done has been only either on Alzheimer or on Parkinson alone. Most of the publications are available on either single disease, or one of them can be Parkinson or could be Alzheimer, but up to the time when this paper was sent for publication, for review, only one paper worked on trying to explore the performance of the models when it comes to these two diseases. And this brings us to the point, what do they have in common? Mostly they have issue in a brain. All of them affect brain. So MRI now become a vital tools which can help us to discern and detect, but also being able to differentiate between Alzheimer and other disease. And this actually is focusing on hybrid model, which was developed. So here is a schematic overview of the hybrid model. And the proposed model was swine VIT. Later on, to bring the benchmark, other model, also the transformer model, will be discussed. But as harnessing the strength of hybrid, so this is the structure. We have a MRI image of either Parkinson or Alzheimer, or anyone who doesn't, who is the free, I mean, is earthly control, means it's not either Parkinson or non-Alzheimer. And to do that one, as I said previously, that we could find only one person, but it didn't do hybrid, did only on the transformer, explore transformer, but it didn't include any other hybrid. So the aim of the study was to explore incorporation of transformer, but also with hybrid. And the focus was more on the hybrid, but also we have a benchmark on the other model. To test this MRI image, about 7,839 from Kego was explored. And as you can see, it shows we had about 3,672 who are free from any of them. We had about 3,200 of Alzheimer and 967 Parkinson. And you can see this was imbalance in some way, Parkinson having less number, and a little bit etheric control and Alzheimer having almost the same. So imbalance, we did downsampling, original set, and augmentation. So means, or otherwise you can say upsampling, means on the case of upsampling, all the image were upsampled to the minimum, meaning the training set of the highest class. And also we are normalized and set into 224 size. And so in addition of the other mode I said, we have aiming at the hybrid, but also other model were established to bring in the benchmarker to try to check the performance of the hybrid and also the other standalone transformer. And you can see vision transformer was applied, but also swine, which is separate. So on the training, vision transformer is analyzed as itself, but also analyzed as when combined with swine. And as you can see, this is another kind of transformer model dealing with image or dealing with vision. Another model was medical transformer, which was applied. Another model was data efficient image transformer, which is also a VIT, which is vision transformer variant. This is meant for smaller data set. The other model, they work better for the huge data set. So this was designed to solve the case. Now, how the experiment was done. So the experiment was done in Google Cloud Pro with about 1.6 terabytes per second. And the framework used was PyTorch, and also Python and Skyline was applied. Now let's look into the result after we have implemented this model. And as I said, we are trying to harness the power of hybrid, but also the power of the other model and see which work better. And then we come to the conclusion. So on the original dataset, which said before, means this was the performance. As you can see, the accuracy for each model. We discussed it each individually, and also we can see on the other end, the hybrid one. So on this case, we can see that VIT had a best performance. And you can see the minimum in the accuracy was ranging between 89 to 95. One of the metrics, which is false negative rate, was less than 8 for most of the model. Another metrics, which is precision, recall, also were aligned. So, and the model with high accuracy, you can see, was VIT. So now let me look onto the visualization of the image. But remember, the image are not balanced. Remember, we used the original image and it's not balanced. So if you look onto the training trend, you can see the way Parkinson here was misclassified, because as less data, you can see the way the coloring is not very okay. You can see it as some kind of misclassification on that. And now, to try to solve the issue, because we used the original, which is unbalanced, we went ahead and tried to downsample, means bring all the image to the same size of Parkinson, which is 967, and look onto the performance. So when you look onto the performance, you can see the performance went down. And why? Because this model, actually, you can see it was ranging between 85 to 89, and specificity was about that 92. False negative rate was about 99 to 22, and you can see the performance was low, and we can come to the conclusion that yes, because transformer model are better when we have huge data set. And in this case, you can see.
Sorry to interrupt, Center, but you have 2 minutes to conclude.
Okay, sure. You can see that the DET was having high performance, and as we saw from the introduction, that as you work well with data. Okay, now you can see there was kind of fair classification based on the image. And now going to upsampled means the image were increased. So the original set was 20% of each original set was taken out, and then the remaining was upsampled to be this every class to have the same number, which was 3010. And this is the performance. You can see it's not that big, but not that small. You can see the swine, the transformer model of hybrid, performed better than in another model. And there was some changes, and you see the performance. The hybrid model had a best performance, and you can see the visualization. And looking onto analysis, you can see that when we used original data set, there was no correlation. You can see this model, there's no any model which had a correlation in all the metrics. But when we did undersampling, you can see the classification, I mean the model which had a huge performance, it maintained the best performance in each metrics measuring. The same when we upsampled, you can still see the model had a performance. And when you check the comparison of the other model, actually, this was a study we could find which had the performance, and you can see the performance. And actually, it was tried only on this model. And we did some kind of clustering. What if we don't label the image? And these are kind of results from the clustering. So at the future election, as we can see, it is possible to distinguish between these two diseases, and but you need a huge data set. And as a future study, we would like to explore on more large data set, but also undergo math model integration and also apply explainable AI. Thank you.
I'm audible?
Yes.
Acha. You said two models, BIT model and VIT model. Sometimes it was said that the PIT model is better, and sometimes it is said that VIT model is better. So what is your conclusion?
Okay, can you say it again, please? I didn't get the question. Okay, VIT was better. Okay.
And VIT. Compare these two.
VIT and what?
DEIT.
Okay. DEIT, right? So
Yes.
DEIT worked better when we had a low data sample. And when we had huge data set, which is not balanced, VIT, Vision Transformer, performed better. But when we had a huge data set, well balanced, the hybrid model performed better.
Okay. Image size downside you have taken 54 by 254, isn't it? But
Can you?
yeah, image size downside you have taken 224
Okay.
by 224.
Okay.
But it was said that the better would be 512 by 512. Then
Okay.
can you justify why you have taken 224?
Okay, so I was using PyTorch and I was using the built-in transformer model, okay, the pre-trained transformer model. So they are set to use 224, means 224 size. That's why I use that one for this case.
Right.
Possible to work with 5. That would be a good question to try. What if this image was 512? And what
Right.
would be the
Good. Yeah, yeah. Good presentation, good research support. Wish you all the best.
Thank you so much.
Thank you, sir. Thank you, sir. Now moving towards the next presentation. For the next presentation, I like to call Daniel for the paper title AI-assisted chest X-ray reading improves sensitivity without reducing specificity, a crossover study. I request the presenter to kindly proceed with their presentation. Moving to the next presentation, I like to call Prince Kelvin for the paper title An Evaluation of Mini-Grid Integration in Island Communities on the Volta Lake in Ghana. I request the presenter to kindly proceed with their presentation.
Okay, thank you. Start sharing now. This is it visible now?
Yes, sir. You can proceed.
Now yes.
Okay.
Now yes.
Thank you very much. I'm pleased to present on the topic, an evaluation of mini-grid integration in the island communities in Ghana. So this study explores the market feasibility, the challenges, and then the prospects of integrating the mini-grid in the island communities in Ghana. So Ghana has made an impressive stride of expanding their electricity assets. So in the urban areas, they have about 90% in the, and then the rural areas, they have 67%. So but the remote island communities are still underserved. They still remain underserved due to high cost of the grid expansion. And then globally, the electrification in remote areas also still faces similar issues, often relying on fossil fuels and fossil fuels. Yeah. So the mini grid, especially solar and the hydro-powered are a promising upgrade solutions, but aligning with Ghana's renewable energy master plan, aligning with the Ghana Energy Master Plan. So this still face challenges, mainly due to financial, technical, and then policy-related issues. So our national goal is to adopt and deploy over 300 mini-grids by 2030, but they are still in process. So the Ghana Renewable Energy Master Plan aims to increase by 300 mini-grids by 2030, and then at least 70% renewable energy sources. So approximately 200 out of 2,000 island out of 2,000 on the island lake in Ghana are habitable but underserved. They are all underserved. And then Ghana has abundant renewable energy sources. That's the hydro, solar, wind, and wave, tidal, biomass, and waste energy. So we have so as a result, this study emphasizes on utilizing utility-led and then public-driven deployment model instead of purely market-driven ones. So moving on to the methodology, we use the exploratory sequential mixed method approach, which combines the qualitative and then the quantitative analysis. We use 12 purposively selected participants from key stakeholders. That's including officials from the Energy Commission and then the Energy Commission and the Ministry of Energy, and then the qualitative phase had a structured survey that was administered to our to 60 stakeholders across utilities, then NGOs, and then academia and financial institutions. So using the analytical hierarchy process, that's AHP, we ranked like 20 challenges classified into 5 categories: into academic, into economic, political, and technical, and then environmental and social. So pairwise comparison helped us to generate weights, weights and then consistency ratios to ensure reliability responses. So the findings, with the findings using the AHP results, using the AHP, the results revealed that economic challenges were the most significant at 38.74%, led by a lack of finance. And then the political challenges ranked second. That's 33%, especially ineffective and constitutional structures. And then technical challenges also ranked third. That's including the island access that has 27.78%, and then a poor maintenance culture. So the environmental challenges also had the fourth position. That's they had the least weight of 7.8, but 100% that was due to low environmental awareness. And then social challenges were also the lowest. That's 5.42%, with the political interference and then procurement delays as the top issue. So moving on to the discussion. So Ghana's mini-grid models is mostly public sector driven. So supported by donors like the World Bank, and they are supported by donors like the World Bank. However, this model is unsustainable long term due to finding risk and then institutional weakness. So including we identified some barriers that hinder the integration of the mini-grid community, the mini-grid in the island communities in Ghana. One of them being economic hurdle. That's the currency violation, currency volatility, and then consumer poverty, and then limited financing. So the currency volatility has to do with the dollar rates and then our local currency. And then another hurdle has to do with the political hurdle. That's poor institutional frameworks and then unclear grade extension policies. The third one has to do with the technical, so the infrastructure limitations and then poor maintenance. So the private sector involvement is also currently restricted to EPC role, and then concentration on wealthier areas. So to scale up, we recommended that regulation reforms to allow more private sectors participation, and then creation of a single coordinating body as as required by the renewable energy, and then diversification of funding models, and then introduction of flexible and rural-friendly payment system. So in conclusion, Ghana has completed 5 mini-grid pilots, with 3 more underway. So they are all mostly funded by public institutions and then donors. So our AHP analysis confirmed that economic challenges, especially the access to finances, are the most greatest hurdle, and then political and then technical issues follow closely, and then the sustainability of mini grids in the water lake communities depends on board reforms in policy and business models and stakeholder collaborations. So further research we recommended should examine the private sector delivery models and then the use of financial technologies. So finally, we recommended that the integration of smart energy systems like IoT and then smart grids to address the access and then to address access and monitoring access monitoring and readability challenges. So here is the end of my presentation. Thank you very much. Is am I audible?
Yes, sir. I request
Yes,
session.
you are audible. Yes, yes, sir. Dear team, you are given good presentation. You said adaptive payment should be there. Can you tell me how we can make adaptive payment? What are the way to make adaptive payment? What are your suggestions?
Okay, so my suggestions is to just have like you're talking about adaptable payment, am I right?
Yes, yes.
Okay, so the adaptable payments, we have we can have systems in place that will make payments really swift, so that making payments from the rural areas will just be simple, so that sending the mini grids over there and then the electricity access over there will be easily accessed as compared to those in the rural the urban areas. So in the urban areas here, we have access to electricity that we can make the payment directly through a mobile phone. So you can just be at the comfort of your home, and then you make payments through the mobile phone, and automatically it renews your prepaid. So as sending these sending these mini grids to the underserved communities in the rural areas, having swift payment systems would be greatly acknowledged. Thank you very much.
Thank you, sir.
Yeah,
Now,
it is okay. Karthik, 1 minute.
yes,
Prince, good presentation. Wish you all the best. Over to Karthik.
Okay, thank you very much. Thank you very much.
thank you, sir. Thank you, sir. Now, moving towards the next presentation. For the next presentation, I like to call Prince Kelvin for the paper title Augmented Reality AR and Virtual Reality VR in the Marketing and Advertising, Pioneering Innovation in Ghana's Communication Landscape. I request the presenter to kindly proceed with their presentation.
Okay, so I'll also be presenting on this paper as well. Thank you for the opportunity. Okay, thank you very much. So I'm presenting on the paper augmented reality and then virtual reality in the marketing advertising. So we are pioneering innovations in the Ghana communication landscape. Please, can you go to the next slide? Next slide. So augmented reality and then virtual reality are influencing the markets and then advertising in Ghana. So these technologies are transforming global communication strategies, but their impact in Ghana is still underexplored. So Ghana's growing digital economy the use of smartphone, and then the tech savvy youth population creates a promising environment for immersive markets. But however, challenges such as high costs and then the limited technical expertise and infrastructure gaps still persist. So this study explores the current state of AR and VR adoption in Ghana's marketing, and then the impact on consumer engagement and brand perception. And lastly, the barriers and then the enablers to their implementation. Please can you go to the literature review. So our literature review shows that globally, AR and VR enhance consumer engagement through interactive and storytelling. However, in sub-Saharan Africa, including Ghana and Nigeria, usage is still emerging due to the infrastructure and then financial constraints. So a major gap exists in the research, specifically focusing on AR and then VR marketing in Ghana. So most studies treat AR and VR as part of a general innovative without addressing their unique strategic contribution. So additionally, please can you move to the next slide. Additionally, while pilot projects are being okay, thank you very much. Yeah. Okay, let me finish with this. While pilot projects are being tested in retail and tourism, there's a little data on performance, on user feedback, and then our study aims to just fill these gaps by using real data from industry professionals and then the consumers. Please can we move on to the methodology? So with the methodology, in order for us to get the a complete picture, we use the mixed method approach. So using the qualitative, we conducted interviews with 15 markets professionals in Accra, Kumasi. That's one. Those are the big cities in Ghana. So Accra, Kumasi, and Takrady. And then the qualitative, we surveyed about 250 consumers who had interacted with AR and VR arts in retail and then real estate and tourism. So we use the purposive and then stratified sampling to ensure diverse and then relevant perspective. So data was analyzed using the niveau for teams and then the SPSS for statistical trend. So we followed ethical guidelines ensuring confidentiality and then informed consent through the process. Please can we move on to the findings? Okay, so the findings, we had reviewed like 4 major points. So the first one being the awareness. So we had the high awareness is high, but only few firms have implemented AI and VR, mostly through pilot projects. And then consumers found AR and VR ads as engaging. So we have 72% rated the experience of us engaging, especially those aged in the young age ones. And then the third one improved the AR and VR improved brand record and loyalty. So 68% remembering brands, and then 55% are likely to purchase. So the barriers to the adoption include high cost device access and then lack of expertise in the AR and VR in Ghana. So our discussion, these results align with global trends showing that immersive technologies increase consumer engagement and brand connections. However, implementation in Ghana is still experimental and then relies heavily on the foreign expertise, raising sustainability concerns. So consumers want this experience, but devices access is still low, and then only 29% have regular access to AR and VR capable devices. So moving forward, what we need to do is to just build local talent. So we need to build local talent that will be able to control and implement AI and VR locally, and then increase public-private collaborations. And then lastly, create scalability and then mobile-friendly AR and VR content. So please can I move on to the conclusion? So in our conclusion, we have a high AI and VR have high potential to revolutionize the Ghana marketing industry. And then consumers are capable, receptive, and then showing strong emotional responses, especially to culturally relevant campaigns. So adoption is still limited by that cost, access, and then skills. So these must be addressed to ensure that AR and VR can be easily be implemented in Ghana. So we recommend that in our recommendation, we recommend that mobile optimized AR experience, and then government supports through subsidies and then training, and then public-private partnerships for infrastructure and then skills development would also help the implementation. So with the right investment and then collaboration, Ghana can fully leverage immersive technology for digital transformation. So here comes the end of my presentation. Thank you very much, and then have a good day. Thank you.
So, I'm audible? Hope so. Hi, please.
Sir.
Yeah, you were saying about sustainability. Do you know
Okay.
all sustainability goals given by UNESCO?
Please can you come again?
Do you know all sustainability goals?
Yes, please. Yeah.
Uh, so on which goal we are working here?
Okay, so we are using the goal of let's say the technology.
Acha. But do you think that only one goal will suffice our purpose?
Can you come again?
Can you tell me
Okay,
one sustainability goal
okay,
will addressing one sustainability goal is a
okay.
sufficient thing?
No, we are not only addressing one sustainability goal, we address a lot of them, including um, including the economic growth, and then innovation, and then the infrastructure development.
Okay, good presentation, good research. Wish you all the best. Over to Karthik.
Thank you very much. Yeah.
Thank you, sir. Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call IRIM for the paper title Early Detection of the Lung Cancer by Using Microwave Imaging Antenna System. I request the presenter to kindly proceed with their presentation.
Hello, can you hear me?
Yes, ma'am, you're audible to us.
Is it visible?
Yes, ma'am, you can proceed.
Okay. Hello everyone, my name is İrem Yıldırım. Today I'm going to talk about our project called Early Detection of Lung Cancer by using microwave imaging antenna system. Lung cancer is one of the most serious health problems in the world today. Recent reports show that both the number of cases and the number of deaths caused by lung cancer are increasing rapidly. In India, for example, lung cancer cases have gone up by 5% in just the past 2 years. According to American Cancer Society, lung cancer is the leading cause of cancer death for both men and women in the United States. It causes almost 25% of all cancer deaths. These numbers show how important early diagnosis and better detection methods are. This study focuses on using microwave imaging and spatial antenna design to help detect lung cancer at earlier stages. Lung cancer continues to be the top cause of cancer-related deaths around the world. One of the main reasons is that it's usually diagnosed at a very late stage, when treatment options are limited and survival chances are low. Conventional imaging techniques such as CT and MRI come with several drawbacks. They are so expensive, expose patients to radiation, and often fail to detect tumors in their early stage. In addition, many existing diagnostic tools are not sensitive enough to detect small or subtle change in tissue. This lack of precision makes early detection difficult, delaying treatment and reducing the chance of successful outcomes. Therefore, there is an urgent need for non-invasive, accurate, and cost-effective diagnostic methods. Study objective is to develop a non-invasive approach for lung cancer diagnosis using UVB microwave imaging based on the analysis of dielectric property differences between healthy and malignant tissues. In this part of the study, we designed a compact and efficient antenna suitable for ultra-wideband microwave imaging. The antenna structure was carefully chosen to support high-frequency signals and ensure stable performance. To enhance the signal quality and broaden the operating range, we introduced spatial cuts into the antenna design. Additionally, the connection line was adjusted to ensure smooth transmission between the antenna and the imaging system. To better simulate how signals behave in the human body, we created a realistic lung model using 6 different layers. These layers include skin, fat, muscle, bone, lung tissue, and a spherical tumor placed inside. Each layer was carefully defined with realistic properties such as how it reacts to electric and magnetic signals. This helps the model behave similarly to human chest in real life, making the results more accurate and useful testing the antenna and imaging system. As for one parameter, the parameter helps us to understand how well the antenna sends and receives signals. If this value is below -10 decibel, it means the antenna is working efficiently and not reflecting back much of the signal. In our design, the antenna showed good performance at 3 frequency points. Also, results from 2 different simulation tools, these are CST and HFSS, were very similar, which confirms that the antenna works well across multiple frequencies. This proves that our antenna is suitable for wideband and multiband applications. At different frequencies, the antenna shows various signal spreading behaviors. Sometimes it sends signals in 2 directions, and sometimes it becomes more focused in the one direction. As the frequency increases, especially at 9.54 GHz, the antenna becomes more directional, which is ideal for imaging purpose. Overall, the radiation patterns prove that the antenna can control signal direction well, a key requirement for accurate microwave imaging. As the frequency increases, both the gain and efficiency of the antenna improve. At 9.54 GHz, the antenna reaches its best performance with strong signal strength and very efficient radiation. This makes the antenna highly suitable for medical imaging, where both power and clarity were important. The current distribution on the antenna surface changes with frequency. At lower frequencies, the current is concentrated in specific areas. As the frequency increases, the current becomes more evenly distributed across the surface. This smoother distribution, especially visible at higher frequencies, is a sign that the antenna supports stable operation and performs effectively across multiple frequency bands, which is essential for imaging applications. In this system, we use a simplified model of human lung. Two antennas are placed on opposite sides. One sends microwave signals and the other receives them after they pass through the tissue. The idea is simple. Healthy and cancerous tissues react differently to microwave signals. If there is no tumor, it changes the signal in a noticeable way. This change helps us detect where the tumor is and even estimate its size without needing surgery or harmful radiation. Results, we tested how the system responds in three cases: no tumor, a 50 millimeter tumor, and 30 millimeter tumor. The results showed clear differences in the signal, both in amplitude and timing. In particular, in 30 millimeter tumor caused a stronger signal reflection and noticeable delay, which means the system successfully detects the presence and size of tumor. This proves that our antenna is sensitive enough to identify change in tissue and is effective for detecting cancer areas. When we compare the proposed antenna with those from previous studies, we can see that it offers a wide bandwidth of over 9 GHz and a gain of around 4.5 decibels. Its compact size and ability to detect tumors as small as 15 millimeters make it highly suitable for microwave imaging. While some earlier designs achieved slightly higher gain, they often required larger size or worked over narrower frequency range. Our antenna achieves a good balance between size, performance, and tumor detectability, making it a competitive and efficient solution. First, we designed a compact UVB microstrip antenna for lung imaging. Then we run electromagnetic simulations to evaluate key parameters like return loss, gain, and surface current. Next, we created a 6-layer theoretic model, including a spherical tumor to simulate human tissue. We positioned the transmit and receive antennas opposite each other and tested different scenarios: no tumor, 15 millimeters, and 30 millimeters. Finally, we analyzed the reflected signals, which showed clear differences depending on the tumor size, proving that the system can detect the electric change in tissue. Finally, I would like to talk about what we plan to do in the future. First, we want to build an UVB antenna and test it under real-world conditions. Then, we will compare simulation results with real measurements to check if the system is accurate and reliable. Lastly, we aim to perform clinical tests to see how well the system works in the real medical situations. These steps will help us improve and validate our design. That's the end of my presentation. Thank you so much.
Hi, hello.
Hello.
Acha. Iram, you said about gain. Can you tell me how it is calculated? Hello.
Okay. Um, we use electromagnetic simulation tools like CST and HFSS. We are calculate parameters such as return loss, gain efficiency, and surface current.
I am saying about formula, calculation of gain, how it is calculated.
Sorry?
How it is calculated. Acha, okay, fine, Iram. Okay, fine. Good. Wish you all the best. Over to Karthik.
Thank you.
Thank you, sir. Thank you, ma'am. Moving to the next presentation. For the next presentation, I like to call Manideep for the paper title Sentiment Loss in Pre-Processing, Analysis of Emoji Inclusive versus Emoji Exclusive Methods with Traditional Lexicon Dictionaries and Artificial Intelligence ML/LLM Strategies. I request the presenter to kindly proceed with their presentation.
All right. Am I audible?
Yes, sir, you are audible to us.
All right. Okay. Good afternoon, everyone. I'm Manideep Pendyala. I'm a graduate student at Rutgers University, and it's a genuine privilege to present our work, Sentiment Loss in Processing, Analysis of Emoji Inclusive versus Emoji Exclusive, here at ICTIS 2025. So, whether you're a researcher, a developer, or a product manager, you have likely witnessed firsthand how a simple emoji can change the tone of a sentence, and yet most of the sentiment analysis systems still ignore them. Today, I'll walk you through why that oversight matters and how we measured its impact across several models. So, emojis are standardized Unicode pictographs, tiny symbols um, that let us express emotions, intentions, and nuances in ways that plain text often cannot. Since their inclusion in the Unicode standard over a decade ago, emojis have become a universal language. We now send billions of them each day on platforms from Gmail to Slack, from Twitter to WhatsApp and beyond. So you might think, we just use emojis in casual conversations with our friends, but studies show that even in business environments, the use of emojis is very prevalent. But emojis are not just decorative; they carry tone and subtext. Consider this word "sure." It basically means a polite agreement. If you add a sarcastic emoji, it instantly flips to imply sarcasm. Conversely, the word congrats feels merely polite until you add the celebration emoji, and suddenly the celebration is magnified. So, in customer support chats, an empathetic, I'm sorry to hear that, with a sad emoji can soothe frustration. In peer feedback, a great job with claps emoji can motivate. So, emojis enrich digital conversations with layers of meanings that text alone struggle to convey. Despite their power, most mainstream sentiment analysis pipelines treat emojis as noise. During pre-processing, emojis are either stripped out entirely or mapped to general ASCII placeholders. This approach might simplify tokenization, but it also throws away an entire dimension of emotional insight. For example, take a look at this phrase, "I'm fine," which without emoji, most classifiers would mark it neutral. But if you add a sad emoji, the same words, now with a crying face, instantly register as negative. So when we discard that emoji, the sad face in this case, we are discarding a powerful cue. In applications ranging from social media monitoring to consumer feedback, such omissions can lead to misinterpretations, underestimating dissatisfaction, or missing sarcasm entirely. So, this actually has a serious real world impact. For example, if we talk about empathetic chatbots, Modern chatbots use sentiment score to adapt their responses. A user typing that didn't work with a sad or angry emoji should trigger a more conciliatory human-like response. Studies show that chatbots which respond with emotional cue boost user satisfaction by over 20% and reduce the escalation to human agents by up to 15%. And another example would be during COVID-19 pandemic, healthcare providers built dashboards that monitored patients' social media posts, to gauge the signs of anxiety and depression. So when model detects a negative sentiment spike, which would be signaled by sad emotions emojis, if they are ignored, it would lead to complete misinterpretation of what humans are trying to convey. In all these scenarios, the accuracy of sentiment classification can mean the difference between a timely human-centric response and a missed warning. To close this gap, our work pursues three objectives. First, we quantify how inclusion versus emission of emojis impact the classification accuracy, and we benchmark our performance across three model families, lexicon-based, which are NLTK and VEDAR, which are very traditional sentiment analysis methods and machine learning methods, and LLM-based models. And we advocate for emoji-aware pipelines where emojis are treated as first-class semantic tokens instead of just some sort of pre-processing artifacts. So our key contribution here is a parallel data set and a systematic evaluation of emoji inclusive versus emoji exclusive on various types of models. We assembled a data set of 200 sentences drawn from three sources: public corpora like tweets, reviews, forum posts, and LLM generated examples to cover the edge cases, and human crafted examples. Each sentence appears in two versions, one with emojis and one with an added emoji. We classify these into two groups. First, we call it shift pairs, where an emoji changes the sentiment label. By adding the emoji, we completely change the meaning that the text conveys. And reinforcement pairs, where an emoji amplifies an existing sentiment. We use human annotators to label each version as positive, negative, and neutral, and we reconcile any disagreements to build a gold standard set against which we will be testing all our models. Here in this table, you can see the different distributions in the shift pairs from positive to negative, negative to positive, neutral to positive, and neutral to negative. We try to include as many examples as possible to get a better sense of where the models are lacking. For our methodology, in the lexicon-based methods, we chose NLTK with naive Bayes classifier and Vader. And for machine learning, we combined text blob and a zero-shot BART model. LLMs like DeepSeek R1, Distilbert, Mistral 7B, and Qwen 2.5 were selected because they are the most prevalent in current chatbots. All these models, we use the quantized versions of them along with a few shot learning because most of these models are not inherently classifiers. So we needed to give examples so that the models would give a proper and a consistent response. For, uh, for lexicon-based methods, we split the data into train and test split by using 80-20 split. And for all the evaluation metrics, we chose accuracy, precision, recall, and F1. By comparing each model's performance on emoji inclusive versus emoji exclusive inputs, we isolated that value that emojis contribute. We actually got some pretty interesting results. NLTK with naive Bayes, the accuracy jumped from 39.7 without emoji, 24.4 without emojis to 39.7 with emojis, a significant gain. Vader doesn't show any change because it completely ignores emojis. So we clearly see a difference even for the smallest model, like the most simplest version of it. There is some sort of improvement by adding emojis. And for text blob along with BART, we can see that the accuracy moved from 54.1 to 56.6. And for LLMs, you can actually see a quite significant rise in the classification accuracy. For Quen, it went up from 49.3% to 75.6, a 26.3% rise. For Mistral, it went from 61.5 to 74.1. DeepSeek went from 42.9 to 65.4. And BERT went from 27.8 to 48.8. Across the board, including emojis, consistently boosted every metric: accuracy, precision, recall, and F1. Understanding that even the simplest classifiers can harness emoji tokens as a powerful sentiment indicators. So our key takeaways from this would be that even basic classifiers gain significant performance from emojis, and ignoring emojis risks biased or oversimplified insights in downstream tasks from chatbot to clinical alerts. We strongly advocate building emoji-aware pre-processing pipelines that preserve these pictographs as first-class semantic tokens. In an era where human-computer interaction increasingly relies on nuance and empathy, discarding emojis is no longer acceptable. By treating emojis as essential, we can unlock a richer, more accurate sentiment insights across applications. Thank you all for your attention. I appreciate your time, and I would be delighted to take any questions you might have. Thank you.
Hi, Manjeet.
Hi, sir.
Acha. You said you are using LLM model there, isn't it?
Yes, sir.
Which LLM model you are using?
We use 4 models: DeepSeek R1, Quen 2.5, Mistral 7B, and BART.
So which is better one? You found which is better one?
So at least in our results, we saw that Mistral and Quen outperform the other LLM models.
Reason for it? Your justification for?
So we believe the reason for it is so the other one, BERT, it is quite older model, and it is more meant for like older uh, conversations. And the problem with
Manjeet,
DeepSeek would be,
yeah. Older model
yeah,
is that should not be justification. Algorithmic description or
okay.
efficiency may be the reason for it. The first thing. Second thing, you said about 80-20 model you are using for training and testing. There is also 70-30 model also exist there. So any reason?
Can you repeat it, sir? You were
Yes. Manjeet, you are saying you are using 80-20 model for testing and training.
yeah.
There exists 70-30 model also.
Yeah.
So
So what we saw is it would be a better representation, at least when it comes to this. We tried 70-30, but it didn't give the best results. So what we did is we tried various try and test split, and we chose the whatever gave the best output.
wish you all the best.
Sorry.
Wish you all the best. It is over from my end.
Okay.
Next over to Karthik. Over to Karthik.
Thank you.
Sir, thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Diego Ricardo for the paper title Statistical and ML Analysis to determine the factor that influence student dropout rates in information technology program. I request the presenter to kindly proceed with their presentation.
Good afternoon, everybody.
Good
Continuation.
afternoon, sir.
Share the screen, please.
Yes, sir, you can now share your screen.
Excuse me. statistical and machine learning analysis to determine the factors that influence students' growth rates in information technology programs. Authors: Diego Ricardo Salazar Armijos, Héctor Mauricio Revelo Herrera, Olger Alfredo Zapata Mayorga, Paul Díaz Zúñiga, Aida Noemí Bedón, Nelson Fernando Vinoes Escobar. They are all teachers and researchers at the University of the Armed Forces, ESPE. Engineer Diego Ricardo Salazar Amigos, PhD. I hold a PhD in Human Science, a master's degree in Mathematics and master's degree in Computer Science, and a degree in Electronic Engineering. I currently work in the Computer Science Department at the University of the Armed Forces, ESPE. Astra. Study underpost in IT careers at ESPE 2017 to 2023. Academic and socioeconomic variables were used established within the legal framework of Ecuadorian higher education. Applied models, Grammar-B correlation, logistic regression, and decision trees. Academic performance was the main factor for dropout, followed by external extracurricular causes. Materials and methods. Data from 551 ICTIS students with multiple coded variables. The principal machine learning models are logistic regression and decision tree, preprocessing, cleaning, coding, and PCA. Evaluation with cross-validation and ANOVA. Socioeconomic variables include academic performance, dropout rate, father's occupation, among others. Grammar-B correlation in a first approximation shows that the main cause of dropout is academic performance, followed by the dropout rate, the father's occupation, and motivation. Data preprocessing. Transformations performed before the models were applied. Elimination of errors and null values. Coding of categorical variables. Dimensionality type, normalization and reduction, PCA. Data processing. Data collection, 551 records. Variable encoding, categorical type. Data normalization, common scale. Dimensionality reduction, PCA, 5 components. Data ready for modeling. Resource logistic regression. Regression model with 85% accuracy. Better discrimination capacity, AOC, 0.911. Significant factors: dropout level, income, motivation, and performance. F1 average score, 0.85. The logistic regression model identifies dropout level and performance as variables significantly associated with dropout. The confusion matrix shows good model performance with 94 of 111 cases correctly classified. Accuracy of 78% with relevant socioeconomic variable. Performance and churn as primary nodes. Motivation and math skills are also important. F1 average score 0.77. Results decision tree. The decision tree shows that academic performance, dropout level, and motivation are the most influenced variables for predicting dropout. This is confirmed in the table, where these variables have the highest Gini index and significant p-values. Model comparison. Logistic regression outperforms the decision tree in accuracy. Cross validation with 5, 10, and 15 partition, but with and without PC8, logistic regression demonstrates higher performance. PSI improves the accuracy of both models. Another with PC8 showed significant difference within the results of the models. Logistic regression consistently outperforms the decision tree in both accuracy and AOC, with and without PC8, demonstrating better predictability and lower variability. Additional models. Comparison with other machine learning models algorithms using Orange. Random forest performance better. Logistic regression with better AOC. Accurate but computationally expensive neural network. The result tables with 5 faults. The results the additional models with 5 faults. Conclusions. Academic performance is the main predictor. 95% of dropout occur in the first 3 levels on the decision tree. Vocational guidance and level plans are recommended. Future recommendations. Actions to improve prediction and reduce dropout. Add new socioeconomic variables, for example, disability. Evaluate model based in observation. Include temporal
Kindly request
analysis.
you to increase the volume as we are not able to hear you clearly.
Thank you.
Hello, Diego.
¿Alguna pregunta?
Yeah, you're listening.
I
You said
don't.
about
I don't.
yeah. Acha. You said about temporal analysis. How it is applicable?
¿Cómo esto es aplicable? This is applicable in studies for engineering and IT because como se toman características, se toman características socioeconómicas de los estudiantes. You can take social, so you can analyze social environment of students. Para definir la posibilidad de que estos estudiantes desierten o no desierten. In order to avoid that the students doesn't continue in the career. En nuestro país, Ecuador, se utiliza el marco legal para definir las características.
In our country, we use the legal position to define the characteristics of the studies.
Sin embargo, hay características propias que se añadieron en la misma.
Okay, Diego. Diego, we'll stop here. We'll conclude here. Wish you all the best. Over to Karthik. We will stop here.
Repeat,
We'll
please.
conclude here. We'll conclude here. We'll stop here. Over to Karthik.
Thank you, sir. Thank you, sir, for your presentation.
Thank you. Okay, thank you.
Now we are moving towards the next presentation. This is the last call for Daniel for the paper title AI-assisted chest X-ray reading improves sensitivity without reducing specificity across over study. I request the presenter to kindly proceed with their presentation. Okay, we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9th versions of the conference. We'll be happy to have you in 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 6 to 7 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chair for chairing this session. Sir, this is the token of love and appreciation from the team of Global Knowledge Search Foundation and partners. I request you to kindly address our participants.
Karthik, first of all, I am really thankful to you. You made this journey smooth because moving through the research, it is always roller and coaster ride. You know, probably you have gone through, although you are listening. So I'm really thankful to you for being with me throughout the journey of this particular session. I was very happy to listen the research from coming from different countries and from different domains. Thank you to GR Foundation because they have given the opportunity to move around this journey. Especially research from Clifford and Prince has given 2 presentation. Again, Mandir was a good. It was a the research was appealing at the same time. Research was social driven also. Like one of the research they said about sustainability goals. So it is good that the research is catching up the social issue at the same time. And the second thing is about recent technology and development. Like they are using machine learning models, they are using LLM models, they are using many digital transformation techniques. So it is good to know and good to hear that. I wish all the participants for good luck for their future endeavor. And once again, thanks GR Foundation for inviting me. So thank you, good day and happy researching.
Thank you, sir, for such wise words and lovely wishes. Now I request everyone to kindly turn on their cameras for a quick virtual snapshot of the conference. Thank you, everyone. Have a nice day. Let's meet you in 11th version in 2026.